Have you ever stopped to think about something kinda wild? You can leap out of bed, sprint down the street, or just crash on the couch, and you don't black out. So, what's making that all possible? Well, it's this incredible high-speed system, a silent conductor that's running the show inside you 24/7. Today, we're going to pull back the curtain on exactly how your body manages your blood pressure, literally second by second.
I mean, seriously, how does it do it? How does your body know precisely when to hit the gas and when to slam on the brakes to keep everything in perfect harmony? It's a fantastic biological puzzle, and we're about to solve it.
All right, here's our game plan. First, we're going to find out the one number that your body really cares about when it comes to pressure. Then we'll head to the command center in your brain and meet the sensors that act as its spies. After that, we'll check out some specialist crews that jump in for unique situations. And finally, we'll see how this whole orchestra plays together. Okay, first things first. Before we can understand how the body controls pressure, we need to know exactly what it's measuring. And you know what? It's probably not the number you're thinking of. Yeah, we've all heard the classic 120/80. You've got systolic, the top number, that's the pressure when your heart is actively pumping. And then diastolic, the bottom one, is the pressure when it's resting between beats. But it turns out, your body's internal control system, it's watching something else entirely. And that something else is called the mean arterial pressure, or MAP for short. This is the real MVP. It's the average pressure in your arteries over a single complete heartbeat, and it's the one metric your body is laser-focused on keeping stable. Now, don't let the formula scare you. It's just a simple way to get to that one single, reliable number that tells the real story. So for that textbook 120/80 blood pressure, your MAP works out to be about 93. This is the magic number. This is the target that our internal regulatory system is always aiming for. So burn that number into your brain, 93. It is the key to everything we're about to talk about. So who's in charge of making sure we hit that target of 93? Well, let's meet the command center, which is tucked away deep in your brainstem. And you can think of it as having two main departments, one that's in charge of the accelerator and one that controls the brakes. Deep inside your brainstem, you've got these two key areas that are in a constant tug of war. You've got the pressor area, that's your accelerator. Its whole job is to raise blood pressure by making the heart beat faster and by squeezing your blood vessels. On the other side, you've got the depressor area. That's the brake. It does the exact opposite, slows the heart and lets those vessels relax to bring the pressure down. It's this beautiful, constant push and pull that keeps everything in balance. So how does this accelerator actually work? Well, it has this really clever trick up its sleeve. It squeezes your veins. I want you to picture a tube of toothpaste. When that pressor area sends out the signal, it's like it's squeezing that tube, which pushes a whole lot more blood back toward the heart. And simple physics tells us more blood going into the heart means more blood gets pumped out, which directly jacks up your blood pressure. It's just a brilliant, simple mechanism. But wait a minute. How does the control center in the brain even know when to hit the gas or pump the brakes? It can't just guess. It relies on a constant stream of information from these super sophisticated sensors that are placed at critical points all over your circulatory system. Think of them as watchtowers. The main players on this team are called the arterial baroreceptors. You've got them in some really important spots, like the main arteries in your neck and the big arch of the aorta coming right off your heart. They work by sensing how much the artery wall is stretching. The more it stretches, the higher the pressure must be. And here is the absolutely crucial part. They are always on, constantly sending a live feed of information back to the brain. This is just a fantastic way to think about it. Imagine a foot that is always resting on the brake pedal of that accelerator we just talked about. That is exactly what the baroreceptors are doing. They're not an on-off switch. They're a dimmer. They just press harder on the brakes when pressure gets too high, or they ease up when the pressure starts to drop. It is a system of constant, beautiful, subtle adjustment. So let's just walk through this for a second. Let's say your blood pressure suddenly spikes. The walls of your arteries stretch out, and those baroreceptors start firing signals to the brain way faster. This does two things at once. First, it's like they're slamming that foot down on the brake pedal of the accelerator, basically shutting it down. And second, it activates the actual brake system, the depressor area. The result? Your heart rate slows, your blood vessels widen, and your pressure comes right back down to normal. It's an incredibly elegant and lightning-fast reflex. And, of course, the exact opposite happens if your pressure drops. The baroreceptors fire less often, that foot lifts up off the brake pedal, and that unleashes the pressor area, the accelerator to kick in and bring your pressure right back up where it belongs. Now, these baroreceptors are fantastic for handling those quick moment-to-moment pressure changes. But what about other kinds of problems? Well, for that, the body has specialist crews. Let's meet the teams that deal with things like blood volume and chemical emergencies. So here we have two totally different kinds of alarm systems. On one hand, you've got receptors right in your heart that don't sense pressure, they sense volume. So if you have too much fluid in your system, they're the ones that sound the alarm. And they do something interesting. They work to lower your overall pressure, but they also speed up the heart to help clear out all that excess volume. Then you have the emergency crew, the chemoreceptors. If your oxygen levels ever drop to a dangerous low, they freak out, basically redlining the body's accelerator to restore blood flow and get that oxygen moving right now. So we've met the command center, we've met the main pressure sensors, and we've met the specialist crews. Now let's bring it all together and see how this amazing team works in perfect harmony. This is a really great summary of our regulatory team. You've got the arterial baroreceptors. They're your frontline second-by-second pressure balancers. You've got the atrial receptors. They're your volume managers, dealing with fluid levels. And you've got the chemoreceptors. They are your emergency response team, the ones who jump in when oxygen levels are critical. Each one has a very specific job, and together they cover all the bases. When you boil it all down, what we're really looking at is a nonstop, high-speed conversation. Your arteries are constantly talking to your brain is talking to your heart, and your heart is responding instantly. All of this happening in fractions of a second, without you ever having to think about it. It's truly an elegant system, and it works silently to keep us alive and walking around every single day. But it really makes you wonder, doesn't it? What happens when this incredible, intricate communication network starts to break down? What happens when the sensors get a little less sensitive or the signals start getting crossed? Well, that's where so many long-term health problems begin. And that is a story for another day.